Okay, today our lesson is equations of lines in the plane, which is R2 means two-dimensional. So first let's see the simple equations in R2. In R2 what we have is we have only xy plane, not 3. So in R2 we have this. So we have always xy plane only. So what do we need to have a line in xy plane? How do I get a line? I get a line if I have, number one, 2 points. If I have any 2 points, I can get a line. Or number two, if I have 1 point and one direction vector. One direction vector. Direction vector. This is a direction vector which is like a position vector. So direction vector AB. This direction vector is always parallel to a line passing through a point PO. This is initial point. So I have point XO here, which is initial point. So a direction vector is parallel always to the line. That means if this direction vector is AB, this will be like TAB. It can be shorter or longer than what we have. So we can write this one as a vector equation, which means any point on the line, this is xy, any point, any generic point xy, xy is always equal to xo, the initial point, plus td, which is the parameter. T is always a parameter, it means it can change, it's called a parameter. You can change the values of t depending on the length of your line. So this is called a vector equation. Vector equation. So a vector equation is just xy equal to xo initial point plus t, a parameter, times ab, which is ab is called direction vector. Direction vector has the same direction of the line. If it's parallel to that, it's always have the same direction. So let's see, I'm given 2 points. I'm given points A, 3, 5, and point B, 6, 4. If I'm given 2 points, how do I find direction vector AB? AB, direction vector. Direction vector AB. Direction vector always starts from 0 here. It's AB. So direction vector of AB is the coordinates of B minus the coordinates of A. So 6, 4 minus 3, 5, which is 6 minus 3 is 3, 4 minus 5 is negative 1. Therefore, the direction vector is 3 minus 1. What is the vector equation of this? The vector equation of this will be any point x, o, y, o. I can take either point A or point B, it doesn't matter. So xy, which is a generic point, is always equal to the initial point. I can take A, 3, 5, plus t, the parameter, times the direction vector. So this is a vector equation. If I'm given number 2, let's see, we are given slope is 3/5, slope of a line 3/5. So we say the direction vector, if the line passes through 0, 0, the direction vector is slope is difference in y over difference in x. That is 5, 3. That's the direction vector. Okay, so let's see another format of an equation. Let's see symmetric. If I had vector equation, we said is xy is equal to xo yo plus tab. Let's rearrange this one here. By rearranging this one, I mean x minus xo, we isolate the t, over a is equal to y minus yo over b. AB is direction vector. This is called symmetric equation. Symmetric equation. What the direction vector is AB. Let's see the symmetric equation of the first question we said here. Symmetric equation of this will be x minus initial point, which is x minus 3, which is a point, over direction vector. Direction vector is here 3 minus 1 over 3 is equal to y minus 5. Direction vector is 3 minus 1. So this is symmetric equation. Okay. Now another format of equation we have is called parametric equation. Parametric equations. Parametric equations are when we isolate x. So if I isolate x from this symmetric equation, we get x equal to xo plus t times a, y equal to yo plus t times b. AB is always direction vector. So these are parametric equations of a line. So to see the same example here, the parametric equation of this will be x equals, the point is 3, 5, 3 plus 3t, y equals 5 minus t. The direction vector is 3 minus 1. Okay, so these are the three formats. Cartesian equation is always the same. Cartesian equation, we know it from the previous years. Cartesian equation. Cartesian equation of a line is the same as the standard form we saw, the general form. The general form, which is ax plus by plus c equal to 0. In this case now, in vectors, we say c is constant always. AB is called the normal. AB is called normal. Normal means normal is perpendicular to direction vector. So the normal and direction vector are perpendicular. The dot product is 0. Okay, so let's see one question. Find the value of t if x minus 2 over 5t minus 1 equal to 4 minus y over 3, and x minus 1 over 2 equal to y plus 5 are perpendicular to each other. Okay, so we are finding the value of t if these two are perpendicular. They are both written in symmetric form, but let's see if they are written in the right form. The first one, x minus 2, is okay, but this is 4 minus 1. Symmetric equation is always y minus. It starts always with a variable, not with a number. Therefore, I change this one to x minus 2 over 5t minus 1 equals y minus 4. If I take the negative out, I have to multiply by negative 1 the numerator. So I took out the y out at the beginning, so y minus 4 over negative 3. So now the direction vector here is 5t minus 1 and negative 3. This is a direction vector, d1. In the second one, x minus 1 over 2 equal to y plus 5 over 4. These are in the right format. Therefore, the direction vector of this will be 2, 4. So we are told that they are perpendicular to each other. If they are perpendicular to each other, it means the dot product of the direction vectors must be equal to 0. The dot product must be 0. Therefore, 5t minus 1 minus 3 dot 2, 4 equal to 0. I use a dot product, I multiply this by 2, 10t minus 2 plus negative 3 times 4 is negative 12 equal to 0. Okay, so now this is y minus 4, so 5t minus 3. Okay, this was 2, 4, so this is 12, 5t minus 1, this was 3. Okay, so now we have 10t minus 14 equal to 0. Therefore, 10t equal to 14 and t equal to 14 over 10, or 7 over 5. That's the value of t. Okay, that's our typical examples of this.